Sergey. This is James, Taven, and Chris. And over the course of the last semester, we've been working on designing a handheld thermal neutron radiation detector. So the motivation for our project, Chris has that now. That's a 3-helium proportional gas counter. It's quite bulky, large, fragile, and it comes in at $3,000. The solution that we propose for this problem looks something like this. It comes in at a fraction of the size and, most importantly, a fraction of the cost. So to help you understand how we go about our detection method, we have broken down the process to signal generation, the propagation of the signal, and finally the interpretation of that signal. So to start off, we fabricate diodes that are made out of cadmium sulfide, cadmium telluride, commercial solar cell process. Those diodes are finished off with a 10-boron conversion layer and operate at a reverse bias. Once a neutron interacts with the conversion layer, it has a chance to produce a lithium-7 ion and an alpha particle. That alpha particle is the most important part because it allows us to have a charged particle from a non-charged source. So as that alpha passes through the reverse bias diode, it's going to pass through the depletion region generating electron-hole pairs. Under the electric field of the bias, those pairs are swept off and produce a small spike in current. At this stage, it is crucial to amplify that current and pass it on through the rest of the detection system. In this phase, Chris has been working on the amplification system and is where we saw one of our greatest successes. He has gone through 7 revisions, reducing the size of the circuit by nearly 70% and just over a size of 2 square centimeters. In addition, our testing showed that the amplifier that we have built for under $50 has almost a double in performance compared to the off-the-shelf part that we're using currently, being the Vortex system coming in at nearly $1,400. Finally, it's important for us to continue to minimize the size of this preamplifier because each diode must have this preamplifier. Reducing the size of the preamplifier will let us increase the diode density and therefore increase the efficiency of our detector. Finally, as the signal is amplified, we can pass it off to Taven that uses a microcontroller to be able to receive inputs from multiple diodes. He also is able to process this data and send it off over a Bluetooth radio to James, who has been working on the software. James has developed a PC application and a smartphone application that not only shows the real-time count of the neutrons detected, but in addition, it will leverage the sensors and the connected devices such as GPS and Wi-Fi connectivity to be able to produce GPS coordinates as well as email a detailed log of the detections. Finally, the cell phone will also be able to provide real-time text alerts. So that is the overview of our project, and we welcome you to come by our booth to see a live demo, and we'll entertain any questions. Thank you.
All right, any questions?
Sure.
What was the most difficult challenge that you were able to successfully overcome?
Do you want to talk about the preamplifier size?
Sure. So the original preamplifier was roughly about 1 square inch, and getting that smaller required using smaller package sizes for the individual components and replacing the large components with any alternatives that would make the total board smaller. And I mean, it sort of requires a lot of intuition to sort of see how things fit together more optimally. If you want to learn more, you can come to our poster and I can explain more.
Are you using Handheld diodes or CAD?
So there's 2 sides to this project. For us, it allows us to fabricate these relatively cheaply, but also this process is going to allow us to scale to much larger diodes. So besides handheld devices, we could use this process to fabricate very large detectors that currently, you see this is a very small detector, it costs $3,000. If we're able to scale that process, which has been proven by the commercial solar cell procedure, then we can build much larger detectors also.
So moving to CAD enables you to do smaller size?
No, it's not necessarily going to help us with size, but with cost certainly, because the other alternative for this is, let's say we use a silicon diode, that diode, or a germanium diode, that's going to be much more expensive, but we're not gonna